Okay, so this video is about solving systems of equations. You learn about this in Algebra 2. These are two linear functions, and we're looking for the point where they intersect. So we're looking for a common solution to both functions. So I'll start by showing you how to do graphing. So this is y equals mx plus b. We start with -2, my y-intercept. Slope is -1, so down 1 over 1, up 1 over 1. So the graph looks like this. That's this function right here. I want to graph this one on the same graph and see where they intersect. The y-intercept is +2. Slope is -5. 1, 2, 3, 4, 5 over 1. And so it looks like this. And you can see that they intersect at this point right here, which is 1, -3. So we'll write that here, 1, -3. And what this solution means is that there are infinite solutions to this equation, and there are infinite solutions to this equation, but this is the one solution that they have in common, that they share. If you plug in 1 here, you get -1 minus 2, which is -3. If you plug 1 in here, you get -5 plus 2, which is -3. So this solution works in both equations. And so that's solving a system of equations using graphing. It's not always the best method because sometimes they don't intersect at a nice point. You don't get whole number answers, you get fractional answers, and you would never be able to tell by the graph what the fraction is. So this is the least effective method. So that's why we have substitution and elimination. So this is graphing is a geometric representation. It's a visual. But substitution and elimination are algebraic ways of solving this. Okay, so I'm going to show you a couple methods there. Again, this should be a review for you. In this example, both of these are in slope-intercept form. And so when this says y equals this expression and y equals this expression, we can set these equal to each other because they're both equal to y. So I could say -1x minus 2 is equal to -5x plus 2. This is basically substitution. It's called transitivity because this equals y and this equals y, therefore they're equal to each other. So it's a form of substitution. And now I solve this algebraically. Add 1x to both, actually I'll add 5x to both sides. Keep everything positive. So now I have 4x minus 2 equals 2. Add 2 to both sides. 4x equals 4. So x equals 1, which we know is right because we have it here in the graph that the x value is 1. And then I can just plug it into either function. -1 minus 2 is -3. So I get the point 1, -3. So that's solving algebraically and figuring out that the solution is 1, 3. That's a shared solution. Okay. So let's see. I could also have the same equations just in a different form. So had these been given to me, let's say this one stays the same. I'll rewrite that here. Y equals -1x minus 2. And let's say on this one we move this 5x over here and call it positive 5x. So now we have 5x plus y equals 2. It's still the same problem. It's just in a different format. So let's suppose we had been given this problem in this format and asked to solve the system of equations. In this case, I would have substituted, this says y equals -1x minus 2. So I would have substituted that in for this y right here. So instead of writing 5x plus y, I would have written 5x plus whatever y equals, which is this expression here, -1x minus 2. That's substitution. That's plugging one function into the other function. And again, when you solve it, 5x minus 1x minus 2 equals 2. This is 4x minus 2 equals 2. Add 2 to both sides. 4x equals 4. And again, x equals 1. And then you plug it back into either function, and you'll see that you get -3. So it's the same one. I'm using the same numbers, the same example. I'm just trying to show you different formats that could be given to you. So that's substitution. And And then, of course, there's elimination. Elimination, again, using the same problem if they were given to you in this format. So let's say you have 5x plus y equals 2, same function we had. And let's say we move this 1x over here and call it x plus y equals negative 2. So these are the same two functions. We already know the answer is going to be 1, negative 3. I'm just trying to show you elimination method. So elimination is when they're both given to you in standard form, ax plus by equals c. So this is standard form. So I would just, in this case, subtract in order to eliminate the y's, because y minus y is 0, so you've eliminated the y's. 5x minus 1x equals 4x, and 2 minus negative 2 is 4. And then divide both sides by 4, and you get x equals 1. Again, we know that x is 1. When we plug it in, we get negative 3. So you get the same answer every time. It's just different methods of solving it. Okay? I think I want to show you one example of using a system of a linear and a quadratic. So it doesn't, they don't have to both be linear. So this might be something a little bit new. So let's look at y equals 2x plus 3, and I'll do this one, y equals x squared. So this is a linear, this is a quadratic. So a quick sketch of the graph. I'm not going to plot all the points. This quadratic right here, x squared, we know is a parabola. So basically it looks like this. And this linear starts at 3. We'll just approximate 3 and goes up 2 over 1. So basically you've got something that looks like this. So it's going to intersect at 2 points. And if the graph is nice, in the whole number of answers, we should be able to figure out what those 2 points are. But I'm going to show you how to do it using substitution. Once again, this is called transitivity, because if this expression equals y and this expression equals y, then they must be equal to each other. So I just set them equal to each other and do some algebra here. So x squared equals 2x plus 3. I'm going to move everything to the other side, so minus 2x, x squared minus 2x equals 3, minus 3, x squared minus 2x minus 3 equals 0. Okay, so now I've got a quadratic function here. I can factor it. We'll have to review some factorings. Not everybody's going to be strong with that. And when you factor this, the multiples of 3, we get 1 times 3. Not the multiples, but the factors of 3, rather. You get 1 times 3 is 3. I'm going to make this one negative and this one positive, because if you were to, some of you would say FOIL, or multiply this out, x times x is x squared. This gives me negative 3x. This gives me positive 1x. Together they make negative 2x, and then this is where my negative 3 comes from. So this is what it looks like when you factor it. And then, of course, if you're multiplying this times this and you're getting 0, one of these two factors has to equal 0. So either the x plus 1 has to equal 0, or the x minus 3 has to equal 0. If this is the case, x has to be negative 1. If this is the case, x has to equal 3. So those are my x values. And of course I need y values because we're looking for solutions. Right, so negative 1, 3. And I can just go back to the original function and plug it in. It doesn't matter which function I use. I'll use this one because it's easy. Negative 1 squared is 1, and 3 squared is 9. So these should be my points of intersection. So, which is looks about right. Negative 1, 1, and 3, 9. Which again, if this were a nice graph on a grid paper, you would have seen that those were the points. So this is, again, is a graphic representation, and this is algebraically using substitution. So you're solving a system of equations. This equation is a linear. This one's a quadratic. I used substitution, set them equal, solved it, factored, and then set each term equal to 0 so that I could solve for x, and then plug them back in to get the y. And that's a system of equations.